Hey, welcome back, Matadors. We're still doing the Big Ideas Math Chapter 8 mock test review. This is item number 12. We'll go ahead and read through it, and then we'll go ahead and plan our attack and solve it together. So this is item number 12. A cylinder and a cone have the same volume, so that's very key. They have the same volume. Okay, so if you were to fill them up with water, they would hold the same amount of water, right? That's what this is saying. They have the same volume. The cylinder has a radius of x. So now this is probably a little more abstract than with numerical values, but the cylinder has a radius of x. So r is going to equal another variable, which might seem confusing, x, instead of a number that we're normally used to dealing with, and a height of y. So to top it off, now the height also has another variable. It's y. The cone, so now we're talking about the cone, has a radius of 3x. So it's 3 times the radius as the cylinder. 3x. Find the height of the cone in terms of y. All that last phrase means is that you're going to find the height of a cone, and it's going to have a y in the solution. So the first thing that we're going to do is we're going to write down the formulas for volume of a cylinder and of a cone. And to the left is two generic drawings, depictions of a cylinder and a cone. We're just going to use those to kind of visually get us prepared for what we're about to do next. So again, first thing, let's write the formulas for a cylinder and cone for their volume. And in yellow, you can see that for a cylinder, the volume equals pi times radius squared times the height. In pink, for the cone, you see that the volume equals 1/3 of pi times radius squared times the height. And now we're just going to go ahead and plug in the x for r. So on the left-hand side on the bottom, whenever we see a radius, we're going to actually use x, right? And that's for the cylinder. And whenever we see an r for the cone, it's going to equal 3x, and that's what you see here in the picture as well. Okay? So let's go ahead and now factor in the values that we have. Well, we don't know the volume yet. We don't have to do anything with the pi yet. That can stay the same. But what is the radius of the cylinder? Well, it's x. So instead of r, I'm going to write x squared. And what's the height of the cylinder? It's y. So instead of h, I'm going to replace it with a y. And that's about as far as we can get in terms of the cylinder for now. Let's go ahead and take a look at our cone. So the volume is what we're trying to figure out. The 1/3, we can't change that yet. Even the pi, we can't change that yet. But what do we know about the radius of the cone? Well, we know that it's 3x. So I'm going to write 3x, and we're going to actually square that. And then we're going to multiply it by the height, and instead of h, we're going to use y. So now let me circle this in green. In green, we have the volume of the cylinder and the cone in that line there. When we were doing our reading, it said a key detail is that a cylinder and a cone have what? They have the same volume. So that means their volumes are equal to each other. So that means we can set each of their volumes what? Equal to each other. So now I'm going to write on my next line, well, for my cylinder, I have pi times x squared times y. And we're going to set it equal to the volume of the cone, which is 1/3 times pi times 3x squared times y. Let's go ahead and clean up one portion on the right-hand side, the 3x squared. So let's go ahead and clean this section up real quick. That's 3x times 3x, which is what? 9 and x squared. So we're going to go ahead and replace this section here of 3x squared. We're going to actually write in 3x squared, we're going to write a 9x squared. Okay? So that's the only change that we're making. And now it's just a matter of solving for the height of the cone. So we're actually I'm going to change one thing here. We did want to figure out the height of the cone, and I kind of jumped ahead by accident. This is exactly what we need to figure out. And I don't know why I put y in there. My apologies. But that's what we need to figure out, is that height for the cone. Okay, so now as we're here, we have in yellow, we have pi x squared y equals 1/3 of pi 9x squared times h. And as a reminder, we're trying to figure out what that is. So algebraically, what could we do? What do you notice both sides have in common? Well, they have this pi, so let's get rid of this pi. What else? Well, we have on the left-hand side, we have an x squared. So if I could divide both sides by x squared, I can eliminate my x squared here. But what happens when I divide by x squared here? What cancels out? My x squared. So now on my left-hand side, we're going to clean it up. We have y, and it's going to be equal to something we have not touched yet, is the 1/3. We still have this 9, right? So we're going to multiply this by 9, and we're almost there to isolate our h. So let's simplify this section here. What is 1/3 of 9? In other words, 1/3 times 9 over 1. If we cross cancel, we're left with just 3. So we actually have y equals 3 h. And your last move, what's the last thing to do to get that h by itself? Just simply divide both sides by 3. So we get that h is y over 3. So h is equal to y over 3. So the height of the cone is y over 3.